Let's practice solving a few more radical equations and looking at what it looks like when they become a little more complicated. So if we look at the first equation I have here on the left, number 1, I notice that the square root is the entire left side. Circling the part with the square root can help you remember that that's a chunk that we have to work on by itself. As soon as I see a square root, it doesn't matter what's under the root, whether it's just an x or whether it's an x and some more stuff. Before I can access anything under the root, I have to get all the other terms onto one side of the equation, and then I can use squaring as a way to get the root out of the way. So in this case, since the only thing on the left is the square root of something, I can start out by doing that squaring step. So I'm highlighting what's underneath the root because I want to remind myself that that whole chunk is going to be what's left on the left once I do my squaring. So let's go ahead and square both sides. So we're squaring the left and squaring the right. Squaring the square root leaves just the yellow part on the left side. So I have just the x minus 3. And then on the right side, I've squared 7, so that's 7 times 7, and I get 49. Now my goal is to get x by itself, and I do that by isolating x on the left, since the other thing on the left-hand side right now is a subtraction of 3. If I add 3 to the left and the right, now the only thing left on the left will be x. And on the right-hand side, 49 plus 3 is 52. So that gives me my answer. And remember, whenever I get the answer to an equation, I should always be going back to verify that it makes the equation true. Let's go ahead and do that check in this case. So I'm going to take square root. Instead of writing the x in the equation, I'm replacing it with 52 minus 3. And 52 minus 3 is 49, so I'm taking the square root of 49. And yeah, the square root of 49, sure enough, is 7. So that's my check that I got that the left-hand side of the equation is equal to 7, and therefore I know it works. So let's now ramp it up and go one step more. Again, I start out by looking at where's the square root. Square root of the quantity x plus 1, that's the only part under the root. I notice there's something else on the left-hand side of the equation. So my first step this time, before I can do that squaring step, is that I have got to get rid of this naughty little 5 here. Since that 5 is added there, in order to get rid of it, I'm going to subtract 5 from both sides of the equation. On the left, that leaves me with only my square root x plus 1. Again, remember that square root x plus 1 is alone and isolated, all circled, to remind us that's how it works. And then on the right-hand side, I've taken 10 and subtracted 5, so I left with 5. Now that everything on the left is under a square root, I'm going to square both sides. So now I'm going to do my squaring. On the left, I square the square root. I'm left with what's under the root only. Just the x plus 1. That was what was under the root. And on the right-hand side, if I square 5, I get 25. To get x by itself, I subtract 1 from both sides, and I get x is 24. And just like in the last problem, I can verify that this makes sense by doing my check. I think getting in the habit of doing your check is going to be the best way to not make a silly mistake. Square root of, I want to put in 24 for x, plus 1. Then I'm going to take that square root and then I'm going to add 5 to it. So everything under the root, that's the square root of 25, plus 5. Oh, the square root of 25 is 5. So I get 5 plus 5, and that is equal to 10. which is my right-hand side of my original equation. So I know I'm in good shape. I'm going to pause for a second so I can give myself more space for the third one. All right, let's look at this third one. In this third one, we have the square root of the quantity 2x plus 1. Everything on the left is inside a square root, and it's equal to 7. Because everything inside is under the square root, my first step can be to square both sides. So I'm squaring the root of 2x plus 1, and I'm squaring 7. On the left, it's just the part underneath that's remaining. Remember, I square root. So I get 2x plus 1. And on the right, I get 49. Next thing I'm going to do, I need to get x by itself. Usually it's best to start by taking the terms that are not attached to x directly. So the 1 that was added here, I'm going to get rid of that first by subtracting 1 from both sides. That gives me 2x equals 48. And now because x is multiplied by 2, I can get x by itself by dividing both sides by 2, which would be x equals 24. Just a coincidence that it ends up being the same as the previous problem. I'm just not very creative. But I can check that this makes sense again. So again, to do the check, I write the original equation's left-hand side as I see it. 2 times, because 2 in front of an x means times, I'm going to put in the 24. And add 1. Well, under the root, that's 2 times 24 is 48 plus 1, or the square root of 49, and that is in fact equal to 7. Since that's the right-hand side, which I always abbreviate RHS for right-hand side, I know that I have found the correct solution. Now let's do the last one on this side. Here we've added one more layer in. So this time, look at, here's the square root in number 4. We have 3 times the square root of the quantity 1 minus 2x, and we've set that equal to 12. The 3 is not under the root. Because it's not under the root, I have to get rid of that 3 first. Well, with the 3 written outside there big, that means 3 times that square root. So by dividing both sides of this equation by 3, I can isolate the square root part. (12 divided by 3 is 4. Now, everything on the left is under a square root. So what I'm going to do is square both sides so I can get into that highlighted part on the left. And what I get is the highlighted part, 1 minus 2x equals 4 squared. 4 times 4 is 16. Oop, I need a little more room. Let's make it. So I have 1 minus 2x equals 16. I need to get x by itself. I'm going to choose to get rid of that 1 first, since I have a 1 on the left-hand side of the equation. If I subtract 1 from both sides, that'll eliminate that 1. So what's left is negative 2x on the left and 15 on the right. Last step, divide by the negative 2. X equals negative 15 over 2, which as a decimal expression is negative 7.5. Just like the ones we've done before, we can go in and check that this is in fact the correct solution. We want 3 times the square root of 1 minus 2 times negative 7.5. Okay, well 2 times negative 7.5 would be negative 15. So So we have 3 times the square root of 1 minus a minus 15. When I subtract a negative, that becomes a plus. So I'm looking at 3 times the square root of 16, which is 3 times 4. And yeah, that is in fact equal to 12, which was my right-hand side.